Hey there, I'm Anthony from Optitrack, the Director of Software, and I'm here to talk to you about active I/O and the different types of markers and how they're different from each other. So if you've worked with motion capture before, you've probably used passive markers. Passive markers are what people usually think of when they use motion capture. A lot of people describe them as like ping pong balls that you wear on yourself. They have retroreflective surfaces on them, which means that when the light hits it, it bounces back directly the direction that it came. So how that works is light will come from a camera, it'll hit this passive marker, and then it'll bounce straight back. This is great because these passive markers can be put on basically anything. They can come in sticker form or marker form. They're easy to affix to anything that you need to track, and then just get going. Some downsides of it are the fact that each one of these markers is not uniquely identifiable from each other. And so if you have two of them next to each other, you can't really tell which one's is which unless you have kind of a unique shape of the markers. Other downsides are that you have to emit light from the camera. It has to hit the marker and then it has to go back, right? So you're basically traveling twice the distance you need to travel with the light in order to track this object. So the next type of marker is called, I'm going to call it continuous. So with continuous, you can basically think of this as you have an LED, an infrared LED, and you plug it into a battery. So the battery is not pulsing the signal at all. It's not doing anything special with the electricity. It is just continuously giving power to this LED. So the benefit of it is that these are really easy to set up. I mean, you could just do it with a battery and an LED. It takes no kind of technical knowledge. The downside is that you're wasting about 80% of the power. So in this, you can see that there's an exposure over here. The time at which the LED is on is only when the actual camera is exposing. The light from this marker will go straight to the camera, so it does have the benefit of the light doesn't have to travel both there and back. It just goes one way. But you're wasting about 80% of the power. That's where synced comes in. So synced markers are basically the same as continuous, but instead of spending the power continuously, they are spending it in spikes. So when the camera exposes, you have a spike of power. And so what this does is it takes all the power that you were using and it just throws it all in when the camera is exposing so that the markers will appear brighter to the cameras. So you can see between synced and continuous, you'll see sometimes the brightness be twice or 3 times as much. It works the same way as continuous, where the light is going from the LED back to the camera. And so it's only traveling that one direction. You're using the power more effectively. So synced markers will be much brighter to the camera. And then that's where the last one comes in. The last marker is active I/O. So active I/O works the same way, where you have light going from the marker back to the camera. But in this case, we actually blink the marker on and off between frames. So in the last 3 situations, all of these markers couldn't be identified from each other. The camera would just see them as a bright white spot on its image, and it wouldn't kind of change between frame to frame. With active I/O, the markers are blinking on and off, and so that means that each marker is uniquely identified. They'll blink in binary patterns, so one marker might be ID number 1, or number 2, or 4, 8, 16, et cetera, et cetera. We're able to take every single marker and uniquely identify it from every single one in the scene. So over here on the signal graph, what that would look like is you might expose, and then you might skip one, and then expose and expose again to give it that unique pattern. This allows you to do things like track hundreds of objects at the same time with the same shape. With the passive and all these other modes, you'd have to come up with unique configurations with every single device. It allows us to scale to large volumes. It allows us to get the same benefits as synced. So we have brighter markers that can be seen from farther. It allows us to do a lot more and make our systems overall more powerful. Active I/O is a unique technology that allows you to get the most out of your motion capture system. For synced and continuous, I'm going to come over to this active wand that we have. So the active wand, we don't actually want the markers to identify as active I/O markers. And so we have 2 different modes on it. We have synced and we have continuous. In continuous, if you flip the switch down, it'll allow you to basically have the wand be used with any system without a base station. So this basically means that you don't have to synchronize it. You can calibrate any system without any external synchronization. It will not see as far because you're wasting a lot of the light, but it's nice because no matter what's going on, you can flip it into continuous. It'll always work. And then we also have synced. So if you have a base station and you're synchronizing this device, it'll be multiple times brighter. You can see much farther when it's in synced mode. The LEDs will blink with the strobes of the cameras, and you'll be able to see a lot farther. You'll be able to calibrate bigger spaces. And so we offer both of these modes on the wand for ease of use. If you're in a crunch, you put it in continuous and you just go. If you have everything humming and working great, then you put it into synced mode and you see much farther and can calibrate much easier. And then the last kind of mode is active I/O. So this is a puck. You can see we can have, it has sort of a generic shape to it, and we can have hundreds of these things. So it's not limited to just this one device. You can have a lot of the same shape of device. Over here, I also have a HMD clip. So same sort of situation. You can have 10 of the same HMD in the same space, and you can track them all with this clip because the clip itself actually uniquely identifies itself. The markers on this are in the exact same shapes between every single clip, which makes software configuration easier actually. But it also makes hardware configuration easier because you just pop on the clip, you power it, and you get going. There's no figuring out custom shapes for every single clip in order to track every HMD. The last device to talk about is the base station. The base station is what makes the magic happen. It sends an RF signal to all of your active I/O devices, and the active I/O devices send signals back to the base station, which allows you to make everything happen. So this is what synchronizes everything, but it also gets data off of the active I/O devices like IMU, or GPIO, which is general purpose input output, or other types of data from the tag.